The quiz covers 5.3a equation solving and 5.3b more complex equation solving, because these are really important. Okay, and then 5.4 and 5.5, and these are not broken up by the sections in the book. Okay, they're kind of broken up by 5.4 is the easier stuff, and 5.5 is where you have to do some actual calculations. So that's what's on the quiz, and it's all new. All right. The sheet I passed out today, there is some newly expiring stuff. Okay. All right, it's on the board. The newly expiring stuff is expiring next Wednesday. I highlighted anything that you should think about retaking on your sheet that I passed out, but it is 4.6, 4.7a, 4.7b, 5.1, and 5.2 are all expiring. I know it's a weird day, but it's Wednesday next week because the following day on Thursday we're going to have a quiz, and I don't need 13 of you in here trying to do retakes the same day that I'm grading quizzes, so I'm expiring it on Wednesday. That gives you this week, including Friday. I know we have CareerCon Friday, but if you wanted to stay Friday, I'd be here, okay? And the only meeting I have is Wednesday morning. Any questions about that stuff? All right, did anybody have a I'm panicking homework question they need answered? All right, so let's start looking at review. The first section on the quiz is 5.3, basic equation solving. You were assigned some of these on worksheet 5B. You had to do the evens. I changed this question just because I want to do one that's like on the quiz, all right? So here's my practice for the quiz question. You don't have this exact question, so if you just want to write it down on the quiz review somewhere. If it said 5 cosine x plus 3 equals tangent of x, and it said in the directions, use your calculator to solve in decimals to the nearest, I don't know, 3 decimal places between 0 and 2 pi. Okay, and it says in the directions to that question, use your calculator. So you would go to your calculator, and what mode would you make sure you're in? Okay, radians, because we're graphing. Okay, then it said 5 cosine x plus 3 and tangent of x. I see like 2 people typing. If you start with a zoom trig, okay, there's a lot of intersection points going on, right? But what were the directions? Okay, so you want to go to your window and set x to be 0 to 2 pi only, because those are the only ones you care about. So x min is 0, x max is 2 pi, and it's going to change it to a decimal. Now, you could change the y window if you have to. You could make it go up and down more, but across, these are the only ones we care about. Any intersections here? How many? It looks like 2, right? There's one down here and one up here. Okay? We want to know where they cross. It doesn't matter if it's positive or negative. So if I go second trace, calculate the intersection, enter, 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 it found this one. Anybody get 2.445? Okay. And then if we go second trace, intersection, enter, enter, and we scroll up close to this one somewhere. There I am. It's 1.335. Everybody finding them? Anybody have a question? If you wanted to change your window to be a little higher and lower because you weren't sure you had them all, you don't want to adjust the X because that's the window we care about. There's still only 2 intersections here. Okay, so that's all we have. But make sure you find all the intersection points between 0 and 2 pi. Any questions? So if this were the question on the quiz, you would write x equals, was it 2.445 and 1 point, did anyone write the other one down? 335? Okay. Do not write ordered pairs, guys, right? Because the only variable here is an x. I want to know what x value they intersected at. That's it, not ordered pairs. We good on that question? All right. On the back of the review, there are some questions also like 5.3. So we have basic equation solving. This one says all solutions. What would you do for either of these first two to find all solutions? Actually, I think I want to isolate the tangent. So I'm going to subtract 3 and then divide by 2 so that I get 1 equals the tangent. And where is the tangent 1 on your unit circle? Up here at square root of 2 over 2 and square root of 2 over 2. So that's pi over 4. And it actually happens straight across as well, but tangent always repeats every pi n. So you could put this, if you wrote the other one as well, and you put plus or minus 2 pi n in the back, I wouldn't count it wrong. But tangent does repeat every pi. Okay, so you really only need this. If you're going to put 2 pi n on the back, you'd need both of them, because if I say this one's straight across. But if I want to say I have to go all the way around again, then I need to name both that one and this one. Or I don't hit them all. Number 1, same thing. Do we need to do that one? Just divide by 8. So you'd get the sine of theta would be reduced 4/8 square root of 3 over 2, which would be pi over 3 and 2 pi over 3. Did I do that right? Yeah. And those would both need plus or minus 2 pi n. Okay. And how did I know to put the plus or minus on? It said all solutions, right? All right, what about these next 3? Yep. Yes. They're not. Right. All right. Tangent really is the only one you should be putting plus or minus pi in because that has a period of pi. All right. Anybody, this is probably more complicated looking than what would be on the quiz, but what would you want to do here? Yeah, if we add that cosine squared over here, we'd now have 4 cosine squared. I'm thinking it's going to need to be factored maybe, so we have to make it what? Can only factor when it equals 0. So if we add 4 cosine over here and add 1, then that right side would be 0. How does 4n squared plus 4n plus 1 factor? Plus 1 and plus 1. Everybody good? So it's going to factor 2 cosine squared plus 1 and 2 cosine squared Whoa, whoa, whoa. No squared. Just kidding. It had a squared. We're trying to factor. Eesh. 2 cosine theta plus 1 and 2 cosine theta plus 1, which means that the cosine of theta has to equal -1/2. Be careful. And where does the cosine of theta equal -1/2? 2 pi over 3 and 4 pi over 3? Do I need plus or minus 2 pi n? Nope. Said from 0 to 2 pi up here. So I only need those two solutions. Now, both of the parentheses were the same, and that's why I only solved it once, right? Okay. What about this number 4 over here? Ugh. Square both sides? So it now says 0 equals 2 sine squared minus square root of 2 sine theta. So I'm going to factor out a sine, Christian says, and that would leave 2 sine theta minus square root of 2. So one of these has to equal 0. Sine theta equals 0, or 2 sine minus square root of 2 equals 0, which if I isolate the square root of 2, or the sine, we'll say square root of 2 over 2. Too fast? Lost half of you? No? We okay? What's happening? Okay, where's the sine 0? Remember the direction, 0 to 2 pi? It says less than 2 pi, not including. So it would be 0 and pi, not including 2 pi. And where's the sine square root of 2 over 2? Pi over 4 and 3 pi over 4. Okay. How many of you would have started off by dividing by square root of sine on that first step? Nobody? You're going to remember not to divide by a function? Okay. This one's kind of scared me. What can we do with 5? I think it's not as bad as it looks, maybe. If we subtract this cosine over, what's 4 cosine minus cosine? So we have 3 cosine theta minus 2 square roots of 3 cosine sine. Now, a 2 cosine sine could be a cosine of 2 theta, but I don't think we want to go there. What can we do right now? Yeah, if we take out a cosine, what will it say? So I think we're good, right? Because we have 2 functions, but each one has to equal 0, so we're okay. If this one equaled 0, or 3 minus 2 square roots of 3 sine theta equals 0. Let's see, if I add that over to the other side, it becomes a positive 2 root 3 sine theta. And then I have to divide by 2 square roots of 3. Ugh. But what is 3 over 2 square roots of 3? Yeah. 3 root 3 over 3 times 2 is 6. And then that, I got 3 over 2. Did you get root 3 over 2? Yep. So that was a mess. Okay, we're not done. We still got to find where those happen. The cosine is 0 at? And the sine is square root of 3 over 2 at, all right. Yes, no, how we doing? There is, what? You okay? All right. There is one more on this section. It's a double angle, like one of these. What are these? What did we call these? Yeah, we call these giraffes because you just solve for this and then you worry about the 2 or the 3 at the end, remember? It's called U substitution and it says in the directions to the question may need U substitution. Okay, so what they're saying is call this U. So then you say, where is the cosine negative 1/2? Anybody? It says all, by the way. Cosine is negative 1/2. 2 pi over 3 and 4 pi over 3. Is that right or no, guys? Okay. Plus or minus 2 pi n. Okay. But now what is u really? So what do we still have to do? Yeah. But multiply by 1/2 or divide by 2 to get rid of that 2. You remember this now? Okay. And we're doing this because the 2 is inside here. So we take 1/2, 1/2, 1/2, 1/2, and 1/2. So we're left over here with x equals, what's 1/2 of 2 pi over 3? 2 over 6, which would reduce to 2, 6 reduces, yes, use your calculator, guys. Plus or minus, what happens back here? Yeah, 1/2 of 2 pi n is just pi n. And down here, 1/2 of 4 pi over 3 would be 4 over 6, or 2/3. And 1/2 of 2 pi n would just be pi n. Okay, everybody good on these kind? Where could you find some more practice on that? Remember that pink puzzle was all of those things? Okay, that would be a good place to find some more practice. One more real quick. Where's the sine 3x, or the sine of 3x equals square root of 2 over 2. So if we just call this u, where's the sine square root of 2 over 2? Okay, but u was really 3x, so we need to do what? Yeah, take 1/3 of everything. So 1/3 of 3/4 would just be 1/12. 1/3 of 2 pi would be 2 pi over 3. This would be 3 over 12, which would reduce to 1/4. And this would be 2 over 3 pi n. Now, I will tell you, I was nice, and there aren't any where you have to find only the solutions between 2 pi. Remember that was kind of tricky? You had to start with the first one and then keep adding and make sure you got them all. That's not on there. You're welcome. Are we good on that 5.3a? Okay. 5.3b just has more complicated factoring and stuff. These are on 9a. I don't know if we actually did these Friday, so I'm going to go kind of quick. But what can you trade? If you have a cosine squared and a sine, you're going to kind of be in trouble. Even if you made it 2 cosine squared minus 1 plus sine x, you can't factor anything out. So you're going to have to use a trade. And the directions would say use a trade or something. What could you trade cosine squared for? Yes, 1 minus sine squared. And then there was still a minus 1 plus sine x. Okay, I'm going to distribute the 2. I feel like we did this one Friday in this class. All right. Can I change the signs, guys, so my squared is positive? So I'm going to do this real quick. So I have a 2 sine squared minus the sine x. And then I have a negative 2 plus 1 would be a negative 1. All right, so 2n squared minus n minus 1. Factor that for me. Yeah, I think so. Wouldn't that work? We'd have negative 2n plus 1n would be negative 1n in the middle here. Okay, so here we'd get a negative 1/2, and here we'd get a 1. Are we done? Did we want n? No, we wanted what? What was n? Sine of x. So I need, where is the sine of x negative 1/2 or the sine of x 1? And I don't really have, what do the directions say at the top of this? Let's just go with 0 to 2 pi, okay? If the direction says 0 to 2 pi, what would the solutions be? Sine is negative 1/2, 7 pi over 6 and 11 pi over 6, is that right? And the sine is positive 1 at pi over 2 is the only place, right? All right. I think there's might be one like this on one version of the quiz. I know there's one where you have to trade for a double angle. What is the sine of 2x equal to on your sheet? Double angle. 2 sine of x cosine of x minus cosine of x equals 0. What are we going to do now? Yeah, take out a cosine and it will say what? 2 sine x minus 1. So you have, where is the cosine equal to 0? Or 2 sine x minus 1 equal to 0, which would make sine x equal to 1/2. Can I stop? We've done a lot of these where you get the last step, right? All right. One more off 9a. The problem is if I change this for a 1 minus sine squared, and I'm going to have to move this over to equals, it's just going to be a mess. Okay, you actually maybe could work with that, but what is this equal to? No, if it's cosine squared plus sine squared, it equals 1. Can anybody find the trade for cosine squared minus sine squared? What is it? So it's cosine of 2, ugh, I can't write. Cosine of 2x, right? It's a double angle. Now what would you have to do? Yeah, just look at, ignore that for a minute and say, where is the cosine square root of 3 over 2? Which happens at pi over 6, is that right? And 11 pi over 6? Then what? Yes, we changed. Anytime you're using a double angle in there, you got to do the multiply by half or divide by 2. So we'd have x equals pi over 12 plus or minus pi n and 11 pi over 12 plus or minus pi n. All right, I think that question's on the quiz. I'm not sure it's exactly like that, but it's something similar. There's a question. I'm not going to do this whole question, but what's going on with 6 down here? If I divide so that I have 1/2, and then I square root, what's everybody going to forget? Okay, square root of 1 is 1, square root of 2 is 2, so we get square root of 2 over 2. But somebody said something else. Yes, there are 4 solutions, right? It's got to be plus or minus. Okay. I think that's on there too. All right. Here's some more on the back of the worksheet. It says 11, 12, and 13 are like on the quiz. Let's maybe do 11. What would you do first on 11, maybe? Any ideas at all? We could change sine squared to 1 minus 2 cosine squared. But, yeah, what can we change that to? Because it's a double angle. Okay, there's 3 choices. Why did Kayvon pick that one? Yeah, because we already had a sine squared over here. Where's the equal sign? Way over here? Okay. All right, I'm going to distribute that negative, which made this one kind of tricky. Negative 1 plus 2 sine squared minus 6 sine squared plus 3. What do we get? We add those, we get a 2. We add those, we get a minus 4 sine squared. Now what? Subtract the 2 and divide by the negative 4 so that we've isolated sine squared. What is that? That's 1/2. And what do we need to do next? Yeah, square root. And remember your plus or minus because we square rooted. The square root of 1/2 is 1 over square root of 2 or square root of 2 over 2. So where does that happen, guys? Between 0 and 2 pi. Pi over 4. Everybody good? All right. I'm going to skip 12. Apparently we should do this one. If I subtracted this over to the other side, oh, I don't think that's a good idea. What is cosine squared minus sine squared? It's cosine of 2x, right? But if I still have this, is that looking like anything I can work with? I don't think so. That's a 7, but yeah, I don't think that was our best plan. Anybody have a better plan? What could I just trade that for? So now if I moved it over so it equaled 0 on this side maybe, I'd add a sine squared and subtract 1. So what would I end up with? Okay, so it's really a 2n squared plus 7n plus 3. 2 and 1n. I think if I put a 3 back here, I'll get 6, and 1 is 7. So 2 sine x plus 1 and sine x plus 3. If these are each equal to 0, can sine x ever be negative 3? But over here we get the sine of x equals negative 1/2, which would happen at 7 pi over 6. Someone double check that. And 11 pi over 6, is that where the sine is negative 1/2? And it said all solutions. All right, enough of 5.3b. All right, 5.4 has some simple trades. It also has a proof question like this one. This is off 10a, if you want to practice this one. But it says, on the quiz, it says like expand and has a blank. And then down here it says you're supposed to get it equal to sine x. So how do you expand this? Anybody tell me what sine a plus b equals? So we're going to expand this side, and we're going to use that sine times cosine. Whoops, just kidding. Plus cosine a sine b. But what is a for us? So we're going to put an x here and here. And our b value back here is a 2 pi. So anybody remember what we did next? And I don't know that there's a hint. It had to do with making this noise. Yeah, we flipped it over because we substituted this and this. Okay, so the sine of x times, what is the cosine of 2 pi? And what is the sine at 2 pi? So then what happens? That's just 0, and 1 times the sine of x is just sine of x. Okay? Yes, this was a prove. Remember, it said up here, prove. On the back of your worksheet, maybe 6 and 7 on the back of the review. Are 6 and 7 verified? Yeah. Okay, you want to just do one of them? Yeah. How about 6? What is it cosine a plus b say? Okay, so cosine a plus b off the sheet says cosine cosine minus sine sine. But a is pi over 2 and b is theta. Then what? Unit circle, cosine pi over 2. 0, right? Okay, make sure you... And sine at pi over 2 is 1. So make sure you show, remember this is not, you have to show that step, that show me that's why it comes out 0 over here. And then we have negative 1 times sine theta, which would just be negative sine theta, which matches up here. Okay, just don't skip steps because it's a show question, and that's why I left big long blanks for you to show that. We good on that one? The other thing that's the only other thing that's on that 5.4 section is some of this trading. Okay. So this is off 10B, some practice on this. Can you find one that says on your peach sheet, which will be blue tomorrow, sine times cosine minus cosine times sine? Sine times cosine minus cosine times sine. It is what? Sine of A minus B. But what are A and B for this problem right here? 42 and 17. So sine 42 minus 17, which should simplify to sine of 30/25, and then just leave it. All right, what about number 2? Sine cosine plus sine cosine. What? Oh, look at, they tried to trick us. If this is A and this is B, that's B and that's A, right? So it's sine cosine plus cosine sine. They just wrote it in the wrong order. I don't think I was that tricky on the quiz. What is sine cosine plus cosine sine? It's sine A plus B. Okay, what are A and B? Okay, simplify that for me. What's 1/5 plus 1/2? Math, enter, enter. Okay. So there it is down to a single function. I don't think there's one like 3 on the quiz. What if it just said 2 out here? So it said 2 sine 3x cosine 3x. That could be on the quiz. I didn't put a 16 out front to try to trick you. Can you find 2 times sine times cosine? It's sine of 2 theta. It's a double angle, right? Oh. Anybody spotting it? Yeah, I got it. Okay, but what is theta? 3x. So it's going to be the sine of 2 times 3x, or the sine of 6x. On this one, because it had a 16 out there, you would have had an 8 out in front, but I did not put that on the quiz. What about 4? Yeah, we're running out of time here. At 4, you be okay? I think there was a couple of these on the back. Any of these you need to do? How about just 10? This is on the back of the review. 2 cosine sine is the same as 2 sine cosine, right? And what would that trade for? Two times sine times cosine, guys. It trades for sine of 2 theta, right? But what's theta? So it would be the sine of 2 times 15, or the sine of 30. And you don't have to substitute a value in. It says to here put a value in, but on the quiz it doesn't. Because it isn't one that you... on the quiz it might say sine of 47 or something. It's not going to be something you can substitute, okay? Any questions on those kind? You had some of those to practice on worksheet 7B that was assigned for homework. All right, I want to make sure I get to this. This is on the quiz as 5.5. And I can't stress enough that you need to practice this and be paying attention here, and I can show you where there's some more to practice. What is the first thing you're going to have to do? Pythagorean theorem. Okay, guys, 21 squared plus. When you do negative 20 squared, is it going to come out positive? Okay, what's the hypotenuse here? 21 squared plus negative 20 squared. And then square root 841. think is it 29? Okay. And on this one, x squared plus 7 squared equals 25 squared. Is that one 24? I don't remember. Can everybody do Pythagorean theorem and find those? Okay. So this one, these two say alpha, so we're using this triangle. What's the sine and cosine in this triangle? Sine is 21 over 29. And the cosine is, okay. The second two say use the triangle over here, beta. Okay, what's the sine and cosine? Okay. Can everybody do that part tomorrow on the quiz? Okay, then it says, it actually on the quiz says write out the property. So what is the property for cosine of A minus B on your sheet? And you can use A and B, I don't care. What does it say on your sheet? Cosine A, cosine B, plus sine A, sine B, is that what it says? Now, how are you going to find an exact value here? This is just substituting in numbers. This was alpha. So what is the cosine of alpha up here? Don't lose the signs, okay? Cosine of beta plus sine alpha sine beta. Okay, and now you're supposed to type that in and get an answer. This is negative 480 over what? Can someone do 29 times 25 for me? 675? 725? Did I do the top right or not? 24 times 20 negative?
Yeah, that's right.
Okay, 21 times 7 over here, I think is 84. 29 times 25 is 725. Now what do? Add the top, keep the bottom. 396 negative. But you could have done the whole thing on your calculator, right? Any questions? More practice on that. I think there's some on worksheet 10. I'm not positive. Okay, we got to do one more. This question, where do you draw this? What is this telling you? Pi, 3 pi over 2, yes? Okay, so draw your triangle, and it says the sine is opposite over hypotenuse. If you do Pythagorean theorem here, you get what? But it's going to the left, so it's got to be negative. Okay, what is the trade for sine 2 theta? 2 times the sine times the cosine. So what numbers am I going to put in from this triangle? 2 times the sine, which is negative 4/5, times the cosine, which is negative 3/5, okay? 2 times negative 4 times negative 3 is 24. 1 times 5 is 25. Got it? Okay. So, on the review sheet here, it's at all kinds of places you can find more of these. You see this, guys? Yes? And all of the keys to those should be in the Google Classroom, okay? Homework check due tomorrow. If you have it done and you want to turn it in today, that would be fine.